Bullet physics in video games can be as efficient as hit scan method presented by James Callahan. Out of the box thinkers know that any new idea will need to learn to crawl before running. Though most people tend to be xenophobes, so tend to stay away from anything of the unknown. But the point is innovation never happened because inventors took the safer option. In fact, as many as 6 inventors have died due to their own inventions, like Frank Reichardt, who died trying to fly off the Eiffel Tower using his wingsuit invention. My name is James Callahan. I'm currently studying games programming at Glasgow Caledonian University for an honours degree as part of my final project, although much safer, test our physics experiments. The project's physics simulated bullet trajectory, or PSBT for short, was an out-of-the-box thought that was better than first predicted, and it was from playing first-person shooters as a kid and the knowledge of game development and the curiosity of game mechanics that then resulted in asking, could physics bullets be as efficient as hit scan? Was there a way better that rigid body simulations handle bullet trajectory with physics? To introduce the PSBT system, we will first need to take a look at why. So as previously asked, is there a way to have the best of the hit scan method with rigid body physics with bullets and first person shooters? For those that are unsure about the terminology of first person shooter, it's a video game genre that became a popular genre ever since Wolfenstein 3D released in 1992. Since most of the FPS video games can trace their roots back to Wolfenstein 3D. Particularly with the FPS, there are two main approaches to handling bullets within video games. The first is the hit scan method and the second is the rigid body physics. But the project was to investigate if there was a better approach possibly to handling bullet physics in video games. Bullet physics, also known as ballistic physics, especially exterior and terminal ballistics, specifically for the PSBT system. Exterior ballistics, what happens during the flight of the bullet through the air, and terminal being what happens to the bullet upon impact. And from the initial steps it was established that the bullet is flying a parabolic trajectory. Parabola is a mathematical term that explains a plane curve that is symmetrical, or one may say what goes up must come down. As we can see from the example here, parabolic trajectory maps can start to seem overwhelming. If we put this into a computer system like this, then it would be computationally heavy as sin, cos, tan, to name a few, are computationally demanding on hardware. There has to be math that is more suitable to video games to calculate a trajectory rather than difficult formula like this. It was broke down at the core, and the question was asked, if a bullet was first fired at X speed, how would gravity bring it to the ground? That was easy. For every millisecond of flight, apply gravity equal to the increment of time. As flight progresses, so does time, and the increment continues. Eventually the bullet will hit the ground and give a simulation of bullet drop. Well, that's simple maths. That's just an addition and multiplication by the time step, and this was the proposed solution to the PSBT formula. Now testing what happened was beyond belief. The trajectory of the simulated bullet seemed to have gravity applied, but if we rotate the line of sight to counteract the gravity, what happened then was again fantastic. It began to show a parabolic trajectory with all the simple maths that the system's hardware shouldn't have problems calculating. So now that the project had established a simple formula to compare against traditional bullet systems in first-person shooter video games, it was time to run comparisons with the hit scan method and the rigid body physics and see how it compared to the project system. So comparisons would be run to validate if the possibility of such a system for use in video games could even be possible. First, preliminary validations were to make sure that such a system could simulate physics using similar approaches to the hit scan method and being better than current rigid body simulations and also being able to be as efficient as the hit scan method. Initial findings, as you can see here, seem to compound the hypothesis that physics simulated bullet trajectory can be as efficient as hit scan method. For example, the AIM's 3.78, while the proposed solution is only 4.01. Even though the hit scan is a fraction of a second faster, it can only consider straight lines. The proposed system goes far beyond this, and only for mere fractions of a second extra computation time. But these are only preliminary validations at this stage. But with such results, then exploration of further physics effects can be considered, like terminal ballistics, specifically penetration with velocity loss and recalculated trajectory outcome. And should that be validated to be a success and suitability as efficient as the previous validations, then further considerations will be acted upon in the form of a linear drag model. Now, the first of the additional parameters that would be added to the PSBT calculation would be the terminal ballistics, in particular penetration velocity loss model, which allowed for the impact of the object that was an approximation of drywall that was founded by findings in a research paper about drywall penetration for forensic science. And with the approximation decided and implemented, it was a repeat of the preliminary tests that, due to the previous findings, the rigid body was discontinued and considered not comparable to the proposed PSBT system. As seen from these results, it continues to compound the hypothesis reasoning, and that such a system could in fact find its place in the video game industry. Now that this stage was considered a success, implementation of a linear drag model would be the next stage in development of this system to validate indeed a physics simulated bullet trajectory system can, in fact, be as efficient as the hit scan method. The PSBT system was best in the hit scan method here, and this. With the success of the terminal ballistic penetration model, it was at this stage of the development that the linear drag was implemented. And after all the stages of development, implementation of this additional parameter to the calculation was the simplest, and from how easy it was to implement, the theory that it was not going to impact the calculation much at all was then considered, though looking at these results and finding it was actually more efficient than previous models when simulations were ran. Now many would consider this an error, but in fact, it is actually because the system runs in a predictive style, and thus the linear drag model creates a loss in velocity, and the distance travelled is less, and the overall time of the calculation also in turn is reduced, and this is why the findings in the final comparison test was deemed a success, and rightfully so, with such findings that compound the hypothesis more so than ever. After all the research and experiments carried out, along with the compelling results, it was conclusion that the project was a success and the hypothesis has actually been given a solution. The reason for this being that even though the system did in fact be slower than the hit scan in calculation time, it was only a tenth of a microsecond, which if we think of it, for one click of the fingers, it takes an average of 170,000 microseconds. So you can imagine how little the impact the calculation has extra compared to the hit scan method. And given all the extra simulated physics added, this gave real compelling evidence that such a system could find a place in the video game industry, and potentially groundbreaking, as nothing like this has been done in the last 2 decades from the research done during this project. And with the conclusion to be a success, a demonstration of how the system could potentially be used in video games is up next. As you can see from this demonstration, the raycast can only fire in a straight line and considers only one object and returns upon contact of that object, regardless of the distance from the raycast to the object. It will always return the first object that it makes contact with. On the other hand, the PSBT system does consider distance and also considers gravity, given a parabolic trajectory which can overcome the first object and make contact with the second object. As you can see here, it's similar as the previous findings with the results and the time it takes though it does efficiently create physics simulated trajectories for bullets for video games.